Okay, so the second focus activity of our grading period. Now, the first one I gave you the other day, we started looking at absolute value inequalities, those that were strictly greater than or equal to. And I had this little phrase. It's ridiculous to say, but it does help you remember the strategy. More is or. More refers to a greater than inequality, and you'll set it up as a union, two different inequalities. Now, less is nest means less than, or equal to, but the nest refers to a compound inequality. Okay, so this one here, if I have the absolute value of 3x plus 4 and that's less than 10, what I'm going to do, I'm going to drop the bars. I'm going to go ahead and say 3x plus 4 is less than 10, but I'm also going to state that 3x plus 4 is greater than the opposite of my constant. See, I'm creating an intersection. Okay, this is what it refers to when it says nest. This is a compound inequality. Now, one of our first focus activities of the year had us solving one of these. Now, while you could go ahead and separate it by the word and like we did there and solve two inequalities separately, because I only have the single x in the middle, you can solve both simultaneously. We just have to isolate the x by itself. So how would I get rid of the 4? Yeah, I'd subtract 4. So I'm not only going to subtract 4 from the middle, I'm going to subtract 4 from the left and from the right. So that I have 3x is now greater than negative 14, but is less than 6. Okay, so the nest in the little, I don't want to call it a rhyme, little phrase, is referring to a compound inequality here. So how would I solve for x now? Yeah, just divide through by 3. So it looks to me I'm going to have 14 thirds negative is less than x, which is less than 2. Okay, so only values between these endpoints should make it a true statement. Now, if I wanted to write it as a interval notation, which we typically do, parentheses, negative 14 thirds, comma 2. There we go. Does this seem familiar? Does that kind of remember doing that in Algebra 1? Okay, cool. All right. Now, does it matter? This one was strictly less than, the other one's less than or equal to. Does that change the strategy? No, now it'll slightly change your answer. You know, we'll have brackets instead of parentheses, but the process remains the same. I'm going to say 6r minus 3, okay, is less than or equal to 21, but it is greater than or equal to negative 21. Okay, more is or, the union. Less is nest, the intersection. Okay, so what should 6r be between if I add 3? Negative 18 and 24. So what are my boundaries on r for the solution? Negative 3 and 4. There we go. So with the equality this time, bracket, negative 3, 4. There we go. And if you go ahead and plug in like one of those boundaries like negative 3, 6 times negative 3, negative 18, minus 3 is negative 21. Absolute value makes it positive. That is less than or equal to 21. And we're good. Yes, ma'am. Oh, you can. You can absolutely do that. You could go ahead and say, like for this one here, you could go ahead and say negative 21 less than or equal to 6r minus 3, and 6r minus 3 is less than or equal to 21. Okay. So if you were to look at it graphically, you'd have another one of those situations where one would be shading one way, another would be shading another, and you'd be looking for the intersection, which is your compound inequality. Okay, so good. Now, I'll go ahead and tell you, I did something yesterday that I've never done in my 17 years as an educator. Okay, but you know, there are circumstances this year that kind of make me need to change and kind of adapt with things. You know, we've talked about the number of copies before, and I have to be very careful about that. You'll notice these past 2 quizzes were on half sheets of paper, so I'm trying to do what I can to kind of cut that number down a little bit. But when I go make copies that you do need, like the focus activities, I'm literally only making 2 extra copies, okay, for all the students that I have. So you'll notice that there's not going to be a whole lot left at the end of the day over here. So to kind of compensate for that, I have now posted the focus activities on the website. You still need a printed copy. You can't copy it by hand. I'm still going to stick to that. But if you do happen to lose or misplace one of these activities, go to the website, print off the one you need. Okay? So it is available for you. Okay. Next up, do we have any questions on angles and their measures? I think somebody was asking me, Fernanda, which one were you asking me about? 4. Okay. So what we wanted to do here was draw each angle, then state the reference angle. So let's see here. This is in radians. It's positive, so that means I'm going to rotate what direction? Okay, so counterclockwise, right? Okay, so this is 0, this is pi over 2, this would be 3 pi over 2, and then all the way back around to 2 pi, 1 revolution in radians. Okay, what I would do, what did we do the other day when it's a improper fraction? I changed it to a mixed number. What is 23/4? Okay, it goes in there 5 with a remainder of, okay, so 5 with a remainder of 3 over divisor 4. So we're really looking for 5 3/4 pi. Now remember, half a revolution is pi. Okay, so I'm going to start at the positive x-axis, which we call, starts with an S, standard position. So I'm going to say there's 1. So I've taken care of 1 pi, but I need to go 5 pi. So there's 1, 2, 3, 4, 5. Okay, so I've taken care of the 5. Now I just need to rotate an additional 3/4 of pi. But remember, pi is only half of the circle, right? So 3/4 of that would put me right here. Okay. So this is going to represent 23/4 pi. Now, what's it talking about when it says reference angle? What's that? There you go. The closest, which axis though? Y or X? X. So there you go. The terminal side and the closest x-axis are always what creates the reference angle. So think about this. Let's say I wanted to have 3 revolutions and I got all the way around to 6 pi. Okay. This one right here was 5 3/4. Well, what would represent 6 pi? Wouldn't it be 24 pi over 4? And remember, we only went 5 3/4, which was 23 pi over 4. So all I did was rotate it to make another full revolution. Well, what can I do with those values? I can take the difference. Okay, so 24/4 pi minus 23 pi over 4, we have a reference angle of pi over 4. Okay, that's how much further I would have to rotate to get back to the x-axis. Okay, Fernando, does that make sense? Okay, all right, anything else? Okay. If you do end up having any questions, let me know. Okay. Let's go ahead and do these right here. Now, the inverses are not going to take us a lot of time, but I am going to go ahead and let you know there is way more information about inverses that we need to understand before we can, call it a day. We're going to go ahead and have a really in-depth lesson about this later down the road. I just kind of want to get you used to the idea of being able to take an inverse. Okay, so I'll let you read that. We're going to be looking at inverse sine, cosine, and tangent today. So let's get the idea. Let's say I have cosine. Well, you remember the lesson yesterday? Bless you. What were we plugging into all of those trig functions to get our answers? Anybody tell me? Angle measures, right? Now, all of those were degrees, but it doesn't matter if they're in degrees or if they're in radians. Okay? You input an angle measure into a trig function, and what kind of answers were we getting? Well, they could be decimals if you went and put them in the calculator, but what do those decimals represent? The ratio of what? Side lengths. Now, the particular trig function was going to tell you what sides of a triangle you wanted. Sine was opposite and hypotenuse. Cosine is adjacent and hypotenuse. But the main idea is that if I plug if I input an angle measure into a trig function, what I get as an answer is the ratio of the sides of a right triangle. Okay. That's how we were getting all those fractions yesterday. Remember, I even helped you make the connection by showing you on the calculator and then doing it by hand? Okay. But what if we have the ratio and I want to go ahead and figure out the angle? Well, that's where the inverse comes in. Remember, what are we doing with the quantities in an inverse? What are we doing with all those x's and y's? We switch them, right? So if I'm going to evaluate an inverse trig function, what's my input? There you go. The ratio of the sides of a right triangle. And what do you think my answer is going to be? It's my angle measure. There you go. That's the idea. If we normally evaluate a trig function at an angle, radians or degrees, and I get the ratio of sides of a right triangle, then I evaluate an inverse trig function by plugging in the sides and getting out the angle measure. Okay, so let's try one. Okay, use the trig function to find the measure of theta, round to the nearest degree if necessary. So where they place theta is actually really important. What would 12 be to theta where he's placed? He's the opposite. He's directly across from him, so he's the opposite. 15.7, of course, would be your hypotenuse. So which of these three trig functions would use the opposite hypotenuse? Sine. So let's look at it normally. Sine of theta, whatever angle measure he represents, if I take sine of that angle, I should get the ratio of the opposite 12 over the hypotenuse 15.7. But I want to know what that angle measure is. So now I'm going to evaluate the inverse sine using what? There you go. You evaluate an inverse trig function by plugging in the ratio of those two sides. So 12 over 15.7 should give me the angle measure that I'm looking for. Okay. Now, if you go to your calculator, it's still in the same spot right here next to 7. There's that trig button. Okay. And my calculator is having a seizure. Okay. So let's try that again. There we go. So sine inverse is directly below sine. And this was 12 divided by 15.7. Okay. So I'm going to go ahead and push enter. So the angle used to create those two side lengths, 49.8475. Now this one does say round to the nearest degree. So I would say what? There you go. And that's all there is to it. Or I should say that's all we're going to go ahead and look at today. This is just the basic idea. It's going to take us a while once we get back around to inverses, because there's restrictions on what you put in, and there's restrictions on answers you can get. Okay. All right, let's try another one of these. Okay, use the trig function to find the measure of theta, round to the nearest degree if necessary. Okay, so where theta is placed in this triangle, Noe, what would 11 represent? That's the opposite, so I'll put O. Natalia, what's the 7? That would be the adjacent. So Andrew, what trig function uses opposite and adjacent? Tangent. So I would say tangent of theta, whatever that angle measure is, should give me the opposite 11 over the adjacent 7. Now I want to take the inverse. So again, I'm taking those quantities and I'm going to switch them. So the tangent inverse of the side ratio, 11/7, should give me theta. All right, so somebody help me out with that. Plug it in the calculator. What do we get? To the nearest degree.
30.
Oh, I heard 32. I heard 58. 58. I did get 58 degrees. There we go. So that's 58 degrees. Okay. So also, you don't want to get confused on this. You're only finding theta by using the inverse. That's the only time you're going to use the inverse is to find theta. If you're looking for the ratio of the side lengths, don't need to worry about that. Okay. All right. Now, I just wanted to, like I said, introduce those. The rest of these are not inverse trig problems. I just thought it might be a good idea to kind of see a variety of application problems, a little more challenging than the ones we saw yesterday on that paper, because those were pretty straightforward. Now, we won't have time to do all of these, but let's go ahead and start with this guy. I like this one. Now it says a sightseer on vacation looks down into a deep canyon using binoculars. The angles of depression. Okay, what's that mean? There you go. So like if we're talking about our line of sight, you know, being parallel to the ground, if we look down from that, that's the angle of depression. If we look up from that, that's the angle of elevation. We typically say an angle of ascension. Or you could even have an angle of elevation from the ground itself. Okay. So I'm glad we cleared that up. For a second, I thought the angle was just really sad. Nah, that one's a stretch. Yeah. You know, maybe it was an obtuse angle. I mean, they're always sad because they're never right. What do you think of that one, Zach?
Pretty good.
Pretty good. What? Okay. All right. So the angles of depression to the far and near bank of the river are 61 degrees and 63 degrees respectively. If the canyon is 1,250 feet deep, how wide is the river? Okay, so what I always suggest, and what helps me, because I'm a very visual person, I go ahead and sketch a picture here. So that's my version of a canyon. Not that it's going to be completely flat at the bottom, just for the sake of this problem. Yeah, okay. So let's say we're using the actual height of this cliff over here, because you got a guy standing here. Now we are looking down from him, but we can't use him because we don't know how tall the gentleman is. So we kind of have to believe that our angle of depression is coming from the top of the ground, the cliff face. Does that make sense? Okay. So let's say down here at the bottom of the canyon, we have the river. Okay, right here. So I'm going to go ahead and draw what we know. The first angle of depression to the far edge of the river, what is that? That's 61 degrees, right? Okay. Now we have another angle of depression to the near bank, which is 63 degrees. And it makes sense to look at the far bank, you got to look further down. Is everybody okay with that? Okay. But you'll see, actually, what am I creating here? Two what? Two right triangles. Okay, one inscribed inside of the other. So I'm going to go ahead and draw these over to the side. Here's the first one. Okay. The one that has the 63 degree measure. Okay. And then I got this other one right here, which is going to have a slightly longer base. I'm not the world's best artist, so kind of, there we go, with the 61 degree. All right. Now, which one of these would actually include the width of the river? The first one or the second one? The second one. Okay. So if you're kind of not sure as to what my diagram is actually showing, okay, the river would be right here, and the river would be outside of that triangle right there. Remember, if you went ahead and put one right on top of the other. Is that kind of making more sense? Okay. All right. Well, let's go ahead and say that these angles here are complementary. What does that mean? They equal 90. Okay. So what would this missing angle be here if one is 63? That'd be 27 degrees. What about this one at 61? 29 degrees. Okay. Do we know anything else about these triangles? Okay, we know the height of each one of these is going to be 1,250 feet. Okay. Now, using these two triangles, does anybody think they have an idea of where I'm going with this? How can I find the width of the river? What is one additional piece of information I could use about the two triangles that would help me get that answer? Okay, Philip, what do you think? The bottom right angle? Well, we could. Well, this one here would be 63, and this one here would be 61. Because remember, this line of sight that I've drew, basically the hypotenuse of each one of these would represent the transversal. Because we're going to go ahead and say that the line of sight across the canyon and the floor are parallel to each other. Okay. I mean, we could work off it that way. Yeah. Will, what are you thinking?
Set up a system knowing that the base of the triangle on the right is the base of the triangle on the left plus the rivers. Make like
Okay.
the base of the triangle on the left x and the width of the river y or something like
Okay.
that. Just do a system
Okay.
equation.
You're actually really close to what I did. I made the base of this one x, and I made the base of the other one y.
Yeah.
Yeah, because if I know the lengths of those two bases, well, what can I do with them? What's that, presumption? Oh, not set them equal to each other. Ooh. Well, there it was. Just subtract. Because remember, one of these bases includes the river, but the other one doesn't, right? So if I take the difference, what's got to be left is the width of the river. Okay. So nobody's brought up the idea to go ahead and use the bottom right angles. You could use those to create a trig function. What a lot of people have actually been telling me today, like for this first one here, to solve for x, they would use tangent. Tangent of 27 degrees should equal what? X over 1250. Because remember, what is tangent's ratio? It always wants opposite over adjacent, right? See, then I can do the exact same thing for this triangle. Tangent of 29 degrees equals y, because it's a different base, over 1,250. Okay. Now remember, there are other ways that you could solve the problem. In fact, one thing that actually has been brought up in both first and second periods was the law of sines. Okay. If you're already familiar with that, that's perfect. We haven't talked about it yet, so that's not a method that I'm going to go ahead and use here. How would I solve for x? Yeah, just multiply through like we did yesterday, right? So 1,250 times tangent of 27 degrees. What would y equal? Yeah, 1,250 times the tangent of 29 degrees. Now, when I do subtract, should it be y minus x or x minus y? Should be y minus x because it is a larger base, right? Now, this is one of those times where I would probably just go ahead and type everything in the calculator knowing what I need to do. I've got to take the base, which is going to be 1250 tangent of 29 degrees. So 12, dang it. Let me go back over here real fast. La, 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 la. There we go. Let me see if it does it now. So 1250 times the tangent, okay, of 29. And then I'm going to subtract 1250 times the tangent of 27. Okay. See, I don't even have to round to get those answers and then subtract them. Just let the calculator take care of that answer for me. What should I be getting? Okay. I'm getting like 55.979. So I'd probably just go ahead and say 56 feet. Does that make sense? Okay. Now the next one I really encourage you to go ahead and take a look at. I'm going to help you set up the diagram. But if you go and look at the notes online, you're going to notice I rounded in the problem and I got an answer. It might not be a bad idea to go ahead and try to solve it strictly in the calculator like I just did without rounding and see how the answers compare. Okay. It is slightly different. Okay. So let's see what this one says. The angle of elevation from a hiker to the top of a mountain is 25 degrees. Okay, so let's say a hiker is right here. All right, so we're going to go ahead and say that the angle of elevation is coming from the ground. So here's the ground right here, the angle of elevation. So let's say that represents the top of the mountain. So right now it's 25 degrees. Okay, but then what happens? What's the hiker do? Okay, so he walks closer to the mountain. He walks 1,000 feet closer, and the angle of elevation is now 28 degrees. Okay, so let's say this right here is 1,000. Okay, what are we ultimately trying to find here? Okay, the height of the mountain, right? That's the ultimate goal, the question we have to answer. What would you like me to use to represent the height? H, okay. Let's say H represents the height. Now, I'll tell you what I did just to kind of get it going because we're almost out of time. I said that if he goes ahead and moves 1,000 feet closer, this distance here, okay, the rest of the base was X, so that the base of the entire large triangle was X plus 1,000. Now for this one, I actually did end up creating a system. Okay. I solved each one of these for H, and then I set those equal to each other. Okay. What trig function do you think I'm going to use here? I use tangent again. Because for both of these angles, the height is the opposite, and then the bases are the adjacent. Now, that's not the only way you could set up your diagram. Okay. You could have said, you know, that the entire base is X, so that this other portion right here would have been what? X minus 1,000. So there's different ways you can go ahead and do that. Okay, but I would encourage you take a look at this problem. If you have any issues, come on in. Let me help you with it. Okay. All right. I've got 10:50, so we have less than 2 minutes. Let's go ahead and get those